in this video, we will tackle about the types of database as well as the entity relationship diagrams. So before tackling about the types of database, we'll first define what is a database. So database is a collection of large data stored in an electronic format that is organized so it can be easily stored, managed, update, and retrieved. So generally, the format of data is designed to make reading and update over time. So that's it for the definition of the database. So let's move on to the first type of database, which is the centralized database. So as the name implies, the database is maintained in a central level, and from there, many people or users from different places can access the same database. So in this type of database, the database contains application procedures that help the users to access the data even from a remote location. So in a simpler sense, this type of database is from one database to multiple users. So the next type of the database is the distributed database, which is completely opposite with the first one. So in this type of database, the data is not at one place and is distributed at various sites of an organization. So these sites are connected to each other with the help of communication links, which helps them to access the distributed data easily. So in a simpler sense also, this type of database is from multiple databases to multiple users. So the next type of database is the personal database. So in this database, data is collected and stored on a personal computer, which is small and easily manageable. So the data is generally used by the same department of an organization and is accessed by a small group of people. So it is a single user to single database. So the next type of database is the end user database. End users are different users, and each user have their own role and responsibilities. So from their purpose, these users can access the database. This database can be used in applications. So for example, if you're at the office, the managers will be accessing the database, same as the programmers. So based on role and responsibilities, the users will be divided or categorized. Next one is the commercial database. So in this type of database, the users have to pay for accessing data. So these are the paid versions of the huge databases designed uniquely for the users who want to access the information for help. These databases contain specific, and one cannot afford to maintain such a huge information. So access to such databases is provided through commercial links. So the next type of database is the NoSQL database. So these are used for large sets of distributed data. There are some big data performance issues which are effectively handled by relational databases. Such as kind of issues are easily managed by NoSQL databases. So they are very efficient in analyzing large size and structured data that might be stored at multiple virtual servers of the cloud. So the cloud database, we will talk about that later. So type of the NoSQL database is the graph database. So the graph is a collection of nodes and edges where each node is used to represent an entity and each edge describes the relationship between entities. So in a graph-oriented database or graph database, the database uses graph theory to store, map, and query relationships. So take note that this is also a type of a NoSQL database. So it is a subtype of the NoSQL database. Graph databases are basically used for analyzing interconnections. So for example, companies might use a graph database to mine data about customers from social media. Next one is the most common database, which is the relational database. Data is represented in forms of tables. Each table consists of rows, which is the records, and columns, which are the attributes. Collection of all attributes is called a record. So these databases are categorized by a set of tables where data gets split into a predefined category. The table consists of rows and columns, where the column has an entry for data for a specific category, and rows contain instance for that data, defined according to the category. So the structured query language, or most commonly known as SQL or SQL, is the standard user and application program interface for a relational database. So, in additional, there are various simple operations that can be applied over the table which makes this database easier to extend, which are the join two tables with a common relation and modify all existing applications. So, as mentioned before, the next type of database is the cloud database. So, data is stored in a cloud, and from this cloud, users can access the database. So, we all know that a cloud is a large storage of data in a virtual environment. So, it makes sense because a cloud database is a database that has been organized or built for such a virtualized environment. There are various benefits of a cloud database, some of which are the ability to pay for storage capacity and bandwidth on a per-user basis. And they provide scalability on demand along with high availability. So, the next type of the database is the object-oriented database. So, it is a combination of object-oriented programming or OOP and relational database. So, an object-oriented database is a collection of object-oriented programming and relational database as mentioned before. So, there are various items which are created using object-oriented programming languages like C++, C#, Java, which can be stored in relational databases, but object-oriented databases are well-suited for those items. An object-oriented database is organized around objects rather than actions, and data rather than logic. So, for example, a multimedia record in a relational database can be a definable data object as opposed to an alphanumerical value. So, the 11th type and the last type of a database is the operational database. So, information related to the operations of an enterprise is stored inside this database. Functional lines like marketing, employee relations, customer service, and etc. require such kind of databases. When it comes to organizing data, we often start by compiling everything into a single spreadsheet or table. But that approach isn't scalable. As more data floods the system, a single table will result in misleading information, duplicate data, and errors. A better method is to split your data up into smaller tables that have a narrower focus. These tables organize your data in a more efficient way and come together via relationships to form a database. And a database management system, or DBMS, is the software that handles the storage, retrieval, and updating of the database. So, DBMS are closely related to entity relationship diagrams, or ERD. If you spend any time in a database management system, you know that they typically don't give you the best options for visualizing your database. It's all in the programming language, and it's hard to see where the connections are. That's where ERD come in. It's a visual way of looking at your database structure. Each table translates into an entity, and your columns in each table are listed as attributes in their respective entity. So, let's dig deeper into this entity relationship diagram. So, first we'll define what entity relationship diagram is. So, entity relationship diagrams are comprised of three main categories, which are the entities, attributes, and relationships. So, entities are objects or concepts that are associated with important data like a customer, order, or product. It corresponds to the rows of a database. So, we need someone who will describe that row. So, that's where the attributes come in. Attributes represent properties or traits of an entity, such as a customer's phone number or home address. So, attributes corresponds to the rows of to the columns of the database. So, each entity has attributes which are various properties or traits. But when you have an entity and that entity has attributes, you also need a relationship between those entities. So that's where the cardinality comes in. So relationships can further define to a numerical context, particularly with minimums and maximums through cardinality. So there are different types of cardinality used in connecting relationships between entities in an ERD diagram. So these are the one, many, one and only one, zero or one or many, or zero or many. So when you're building up an ERD diagram or entity relationship diagram, these are the three main components you have to consider.
Hi, my name is Nicole, and I'll be reporting about data types and SQL commands and queries. So first of all, what is a data type? In SQL Server, each column, local variable, expression, and parameter has a related data type. A data type is an attribute that specifies the type of data that the object can hold. It determines the type of data that can be stored in a database table column. So, when we create a table, we must decide on the data type to be used for the column definitions. In addition, we must consider storage requirements and choose data types that allow for efficient storage. As for SQL Server data types, it includes string data types. These types are used to store any kinds of data in the table. In string data types, we have an option to allow users to store either the fixed length of characters or huge length data based on their requirements. In SQL, the character string data types have contained a different type of character data types. Those are char data types and varchar data types. Char data type is used to store a fixed length of characters, while varchar is used to store non-Unicode characters. In SQL, Unicode character string data types are used in situations where we are required to store huge data. So as for numeric data types, these types are useful whenever we want to insert only numeric values in the columns. By using numeric data types, we can define columns that accepts only numeric values. Example in SQL tables, if you want to allow users to store only numeric values in particular column, then we need to define the column as a numeric data type. In SQL, we have two different types of numeric data available, and those are the exact numeric data type and approximate numeric data types. As for date and time data types, we use this when you need to store date and time pieces of information. So when you use date data types, it stores date and time information in both character and numeric data types. It is made of information on century, year, month, date, hour, minute, and second. And on the other hand, timestamp, it is an extension of the date data type. It stores the year, month, day, and the date data type, along with the hour, minute, second, and the second values. It is useful for storing precise time values. So, why is it important to choose the right data type? It is important because choosing the right data types for your tables, stored procedures, and variables does not only improve performance by ensuring a correct execution plan, but it also improves the data integrity by ensuring that the correct data is stored within the database. For example, if you use a date data type for a column of dates, then only valid dates will be stored in this column. However, if you use a character or numeric data types for the column, then eventually someone will be able to store any type of character or numeric data value in the column that does not represent a date. Okay, so again, data types define the characteristics of the data that can be stored in the location such as database column. It's important for us to learn the functions of these data types because data type and length are the most fundamental integrity constraints applied to data in a database. Okay, so for our next topic, we'll be talking about SQL commands and queries. So as you can see in this diagram, SQL commands are divided into 5 categories. They are categorized according to its commands on the basis of functionalities performed by them. So the 5 types of SQL commands can be classified as DDL, which stands for Data Definition Language, DML or Data Manipulation Language, DCL, which means Data Control Language, TCL, which stands for Transaction Control Language, and the last category, which is DQL or Data Query Language. So the DDL or the Data Definition Language, it actually consists of the SQL commands that can be used to define the database schema. It simply deals with the descriptions of the database schema. It is used to create and modify the structure of the database object in the database. So basically, DDL decides how the data should reside in the database. So under DDL commands are create, alter, rename, drop, and truncate commands. Create command is used to create tables or databases. Alter is used to modify the values in the table. Rename is used to rename table or database name. Drop is used to delete the tables from the database, and truncate is used to delete a table from the database. So another category is Data Manipulation Language or DML. These statements are used for managing data within schema objects. This manipulation involves inserting data into database tables, retrieving existing data, deleting data from existing tables, and modify existing data. The commands under DML are insert, delete, update, lock, and merge. So for data control language or DCL, statements are used to create privileges to access limited data. A data control language can be defined as a computer language that is used for controlling privilege in the database. The privileges are required for performing all the database operations, such as creating sequences, views, or tables. The commands under DCL are grant and revoke. So for grant, it is used to provide access to users, while revoke is used to take back the access privileges from users. As for transaction control language, these commands are used to manage transactions in the database. These are used to manage the changes to the data in the table by DML statements. As for rollback, it is used to cancel or undo the changes made in database. For commit, it is used to deploy or apply or save the changes in the database, while for the save point, it is used to save the data on temporary basis in the database. The last one, or the DQL, or the Data Query Language, these statements are used for performing queries on the data within the schema objects. The purpose of this DQL command is to get some schema relation based on the query passed to it. The select command, in combination with other SQL clauses, is used to retrieve and fetch data from the database table, so the basis of the certain conditions applied by the user. So that's it for SQL commands and queries.
For this tutorial, we will tackle about data filtering or manipulation using SQL. In this topic, we will discuss how data is being filtered using SQL commands in order to show a certain output without showing other data from the database. Command select is mostly used for filtering data for the output of the database. There are different ways to filter data depending on what you want to show in the output. You can show all data from the table by using command select asterisk in the query. You can also put conditions on the syntax using the syntax where to filter the data that would be shown in the output. Certain symbols are used for filtering data, and here are the list of symbols you can use for filtering the data. Another method of filtering data is by selecting certain columns from the table to be shown for the output. By inputting the column names on the syntax, you can filter the output by only showing certain columns of the table that are needed. Of course, you can still put a conditions where what data should be filtered from the list of data on the certain tables. If there are two or more lists of data that you want to show but it came from different tables, you can use the command join in order to combine tables and filter out the data you wish to show. In this method, there are 4 types of joins that you can use depending on the need for the database. First, inner join is where there are match fields between two or more tables. In this command, it only returns the values that have matching values in both tables. Left join is where it all returns records from the left table and the matched records on the right table. If there are no matched data on the right table, the output will be shown as null. Right join is where the vice versa of the left join, where it returns all records from the right table and matched records from the left table. Then, if there are no matched data on the left table, the output will be shown as null. Lastly, full join is where the combination of left and right join, where it returns all records from the certain matched records of the left and right table. These are some basic data filtering methods that you can use in SQL. For data manipulation, certain commands are used to manipulate the table or the data itself in the table. Command create is used for the creation of the table or the database, or simply it can use for the creation of the database itself. In this part, you are setting conditions for each column of the table, where you give name, data type, identity, and etc. for each column of the table so that certain data will be accepted on the input of the data. Another thing here is that you can put constraints or conditions on a specific column depending on the use of this column for the database. Command alter is commonly used to add, delete, or modify the columns of an existing table. Command drop is where you are dropping an existing table in a database so that for the next run of the program, the data from the table would not repeat itself on the output. Command insert to is an SQL command where you are adding data to the table. You need to follow certain conditions set per column so that the data would be added to the table. Command update is used in data manipulation where you modify the existing records on the table. Here, you can change the data that was input on a certain column or a specific cell itself in the table. Lastly, for data manipulation, command delete is used to delete an existing records in the table, more likely a row of data in the table or specific data in the table. In all data manipulation commands, you can use condition clauses and operators to specifically manipulate the certain data row or column of the table. These are few basic data filtering manipulation process in SQL that you can use when creating a database in using SQL Server.
I'm Adrian Reyes and I'll be reporting about stored procedure and how to connect database to front-end application. First, we define stored procedure as a type of code in SQL that can be stored for later use and can be used many times. So whenever you need to execute the query, instead of calling it, you can just call the stored procedure. Values can also be passed through this. Using stored procedures has its own benefits, though it doesn't make sense to encapsulate every query you write within a stored procedure. Here are some good reasons to use them. One of the benefits is network efficiency. Stored procedures can include many commands and process large amount of information to obtain the desired result. By keeping all the programming logic on the server, we can avoid having to put query results across the network to be processed by a client program. Another benefit is that stored procedures encapsulate business logic. In order to ensure key business logic remains consistent, it makes sense to run the business logic on the server in stored procedures, rather than rely on each version of a program to implement and properly execute the rules. This helps with consistency as programs execute the same logic. Stored procedures are also maintainable. When complicated business rules and programming logic are centralized into stored procedures, it makes making changes much easier. Rather than having to hunt down areas in each application and make changes, you only need to make changes to the stored procedure. Using stored procedure may bring lots of advantages, but there are some downsides in using it as well. One of which is portability, meaning stored procedures are written in vendor-specific languages and makes it hard to transfer them from one installation, such as Oracle, to another like SQL Server. Another disadvantage is testing. Testing and debugging stored procedures can be tricky. It is more difficult to put together the debugging tools to allow you to step through and trace stored procedures. This is an example of stored procedure. Specifically, the stored procedure accepts the business entity ID as a parameter and uses this to match the primary key of the human resources employee table to return the requested employee, though this example returns a single row, due to the fact we are matching to the primary key. Stored procedures can also be used to return multiple rows, or a singular value. Stored procedures can be called from within SQL Server. It can also be called from within a programming language. Each language, such as PHP or C#, has its specific methods for doing so. So we'll be moving on to the next topic on how to connect database to front-end application. The back-end and front-end both work together to serve a single goal. It is made so that a user can access them. The front-end can take different forms, and it can be daunting to understand how to connect the two. For example, you want to connect a database with a front-end like HTML page. You cannot just directly connect them both. There is always a layer between them. Your HTML page runs on your browser, and a database sits on your database server. Your browser communicates through HTTP protocol to the server. Now the job of your server is to connect to the required database, access the data required, and return them back to your browser. But how does a server do that? For that, you have back-end technologies that run on server and return the response to a request from the server. In connecting a database and front-end, you have to make use of programming languages. A few popular languages in which you can code on server side are PHP, Java, Python, and Node.js. If you want to connect a Java application to a database, the following 5 steps are the basic steps involved in connecting a Java application with a database. First, register the driver. In this step, you need to load the driver class explicitly. Second, create a connection. In this, you would need to use the method of a class to create a connection. Third, create SQL statement. In this step, method is invoked on current connection object to create a SQL statement. Fourth, execute SQL statement. This is where the method of the interface is used to execute SQL statements. And last, closing the connection. After executing SQL statement, you need to close the connection and release the session. The close method of connection interface is used to close the connections. Those are only some of the ways on how you can connect database to front-end application. Thank you.